This is a news article that came out a couple of years ago about speed limits in Edinburgh. Okay, so they're introducing this 20-mile-an-hour speed limit. It's been rolled out over much of Edinburgh already. So when this came out, one of the lecturers, I'm not going to say which one in this department, but one of them wrote this Facebook post, which was basically moaning about his brother. I think is going to take his 1 hour journey into work is now going to take 1.5 hours, and this was terrible. Okay, so we can now go through the line of thinking that this lecturer has gone through. Okay, so we've changed the speed limit from 30 miles an hour to 20 miles an hour. So he's used, he or she, anonymous lecturer, it's a he, a model. Okay, and he's used this model. The model they've used is speed equals distance divided by time. Pretty standard stuff. He's rearranged that model to give himself time. Time takes to work is the distance from his brother's house to his brother's place of work, brother or sister, divided by the speed. Okay. Now, he doesn't need to know how far away his brother is, because you could basically, the old time it took to go to work is the distance divided by the old speed. And the new time it's going to take to work is the same distance. Okay? The speed limit hasn't caused the house to move further away, divided by the new speed. So we don't need to know the distance. We could, so the distance is equal to both of those things in those versions of the equation. So the new time, okay, we can just basically, because the distance is the same, we can then just take, so we can just, because the distance equals the old time divided by the old speed, it also equals the new time times the new speed. So we can just ignore this bit and just use this part of this equation here and rearrange that to figure out the new time. Okay, which is just this times this divided by the new speed, which is what we've got there. So the prediction that they have made, that the 1 hour journey takes 1.5 hours. That seems pretty standard, pretty sensible so far. So we've gone through this process of forming, there's a problem, his brother's late for work, this kind of stuff. He's formed this hypothesis, used the model, okay, and the model has come up with a prediction. And now what we do is we then see if that agrees with reality. So, some people didn't stalk his brother around and time his journey to work, but they did some experiments by basically doing a survey of bus times and working out what they would be if the bus was limited to certain speeds. And it turns out that it would only take 2.5 minutes longer, this hour-long journey, if you change the speed limit. Right? So this doesn't agree with this model, and hopefully, I think you all know what's wrong with the model. Okay, anybody want to say what might be wrong with our simple model?
Traffic.
Yeah. Traffic. So what do you mean by traffic? What's the?
Well, cars could be moving at 15 miles an hour the whole time.
Yeah.
No constant speed.
Yeah.
The traffic light, the way they kind of change, like.
Yeah. So this idea that the speed limit is limiting the speed of the vehicle. It's a bus, right? Which stops all the time. So even if there was no traffic at all, it wouldn't be at its maximum speed all of the time, and it's definitely not at its maximum speed all the time when there's traffic. So there's only a small portion of the journey where the bus would be, if the speed limit was 30 miles an hour, would be in between 20 miles an hour and 30 miles an hour. And that's the only change in the journey time. Okay? So we then need to go back and make a new model that's more complex, that includes accelerations and decelerations, amounts of traffic perhaps. So it doesn't matter really how much longer it'll take. And also this doesn't account that if we have a slower speed limit, more people might ride their bikes or walk to work, and then there'll be less congestion. So maybe the bus will go faster. Okay, so there's always you can always make a more complicated model if you